Hi Dhruva, this is year 2020 and it's a small gift from your mom and dad. This automatic swing for you. When you grow up, the technology would be so advanced that this might look like an old steam engine, but still you might be curious to know how you spent your very young days. Okay, and let us go to a small demo of the unit. So here it is. This is the motor, RS50 motor, and the voltage controller and the power supply unit on a wooden frame. That's the coupling shaft, and that's the pulling cables to the swing. This is a single spring housed swing. Now to get into a little bit of details, let me reduce the rotation. Just stopped it. So as you can see, I'll begin with the motor. That's an RS50 high torque motor. It's 40 kg centimeter stall torque for it. It is connected with a coupling, 8 mm to 5 mm coupling. That's a 3D printer coupling. And this one is an aluminium profile connector. There are two connectors. It is 10 centimeters of length each. It is having holes to it so that you can connect the two connectors and adjust the length from 8 centimeters to 12 centimeters. Currently it's at 12 centimeters. So 12 centimeters is the radius and another 12 centimeters is the total throw for the swing, which is 24 centimeters. That will give a proper resonance for the swing. And the coupling is done using an idler pulley. That's a 3D printer pulley. It's a 5 mm bore pulley with 20 teeth for the grip, and this is housed on an SS shaft here. It has a slight space in between the double nuts, because when the baby swings and this is housed on a single spring, it might be that there could be some lateral movements coming for the swing, and that would be compensated with this gap rather than passing on that load onto the shaft of the motor. This is a silicone strip. This is very durable, very strong and mildly elastic strip, which is connected to a bungee rope. This is an elastic rope which can give a stable pull and push to the swing. Because it is again a single spring swing, we will have to go with a legged approach to connect. Otherwise, any minor variations in the swing will bring large load onto the shaft. But with this two-legged approach, it will bring a greater stability for the swing. And this is a very powerful motor. It is, the operating voltage is between 6 volt and 15 volt. It can take in up to 4.5 amps on full load, but the operating amps is around 2 amps. Then we'll go to the power supply. That's a 15 volt 5 amp power supply, and that is pretty much matching with the load. We have a voltage controlling unit here. This is PWM kit, pulse width modulator kit. It has a knob to vary the voltage from 0 to 100%. And its operating voltage is 10 to 40 volt, but because the feeding voltage is only capped at 15, it operates at 15 as well. It has an inbuilt fuse of 5 amps, so if any load, excess load, can be broken down at the fuse level itself. It has a polarity inverting switch as well, but I would mostly go with a clockwise rotation for the motor. Now with this control knob, I can adjust the voltage and take the motor and swing for the rotation. All of this unit is housed on a wooden platform and it's clamped to the wall with L brackets, but the portion where it actually takes the load, I have given an inverted L to compensate the push and pull motion of the motor, and it's pretty stable, pretty stable. And yes, this is all about the swing and the little boy enjoying his young days. Thank you for watching the video.